Hello students, welcome back to my YouTube channel Sriram Devarajan. Today in this video I am going to discuss a problem from the exercise 1.1 from the chapter 1 real numbers for the CBSE class 10 mathematics students. I already solved the problem from 1 to 4. It is available in my YouTube channel Sriram Devarajan. You may get in the playlist CBSE class 10 max chapter 1. Today in this video I am going to discuss problem number 5, problem number 6 as well as problem number 7. The problem number 5, it is given, check whether 6 power n can end with the digit 0 for any natural number n, for this n. Solution. Before proceed to solve the problem, one must know one important information. If a number ends with 0, prime factor for that number must be 2 into 5. This is important information regarding a number. If a number ends with 0, okay, for example 10 ends with 0. Factors for 10, 2 into 5. Both are prime. For 20, again end with 0. Factors 2 square into 5, that is 2 into 2 into 5. See, here also 2 into 5, here also 2 into 5. Now for 40. 40 means 4 into 10, 2 square, 2 into 5, 2 cube into 5. Here also 2 into 5. Therefore, for all the numbers 10, 20, 40, 50, 60, 70, 80, 100, 1000, last digits are 0. For all those numbers, the factors must be 2 into 5. 2 into 5, 2 into 5, 2 into 5. For example, we go for 80. 80 means 16 into 5. 16 into 5 means 2 power 4 into 5. Here also I am getting factors are 2 and 5. Therefore, which is very important, for a number ends with 0, prime factors must be 2 into 5. Now I am going to find a prime factor for 6. 2, 3. 3, 1. Therefore, 6 can be expressed as 2 into 3, but here given as 6 power n. 2 into 3 power n. Here 6 power n cannot be end with 0 because its prime factor do not contain pair of 2 into 5. For a number n with 0, prime factor must be 2 into 5. But for 6, I am getting only 2 into 3, not 2 into 5 in the form of 2 into 5. I am not getting for 6. If I get 2 into 5 for 6, then we can say the number 6 ends with digit 0. But I am getting the factors are 2 and 3, not in the form of 2 into 5 for 6. Therefore, 6 power n cannot end with digit 0 because prime factors for 6 do not contain the pair of 2 into 5. This is the information for the problem number 5. I am going to discuss the next problem, problem number 6. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. Here two numbers are given in the form of 7 into 11 into 13 plus 13, and also another information 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Whether both are composite, we have to explain why these two numbers are composite number. That's all. You have to check from this information whether it is a composite, from this information whether these also composite. I am going to take the first information as let x equal to 7 into 11 into 13 plus 13, and second information y as 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. First I am going to check whether x is a composite, then I am going to see whether y is a composite. What is x? 7 into 11 into 13 plus 13. Here 13 is there, here also 13. I am taking 13 outside, remaining term 7 into 11 plus 1. 13, 7 into 11, 77 plus 1. 13 into 78. I am going to find the prime factor for 78. 2, 39, 3, 13, 13. Therefore, I am going to write this 78 as 2 into 3 into 13. This can be written as 2 into 3, 13 square. Whether it is a composite number? Yes, it is a composite number. Composite number is a number in which the number must have more than two factors. Prime number is a number in which that number divisible by 1 as well as the same number. Simply says a number which is a prime number, it must have exactly two factors. But for composite number, it has more than two factor. More than two factor means composite, exactly two factor means prime number. But here we have more than two factor. Therefore, this x we have written as 2 into 3 into 13, which is a composite number. Now I am going for y. What is y? 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Here 5 common, take 5 outside. 7 into 6 into 4 into 3 into 2 into 1 plus 1. 5. Multiple all these values. 7 into 6 into 4 into 3 into 2 into 1. 7 into 6 42. 4 3 12. 12 2 24 into 1 24 plus 1, which is equal to 5 into 1008 plus 1, which is equal to 5 into 1009. Here also I am getting a composite number. Already I informed that composite number is a number in which that number must have more than 2 factor. Prime number is a number, it must have exactly 2 factor. More than 2 factor means more than 2. Exactly 2 factor means equal to 2. Here for y also I am getting more than 2 factor, that is 5 into 1009. Therefore here both numbers x and y have factors other than 1. That is the same information. Prime number means only the number as well as the number 1. But here both numbers x and y have factors other than 1 means more than 2 factors. Therefore these numbers are composite number. This is the information for the problem number 6. Explain why these two numbers are composite number. Now I am going to proceed further to discuss the problem number 7, which is a last problem in the exercise 1.1. In the problem 7, it is given as there is a circular path around a sports field. The path is a circular one. Sonia takes 80 minutes to drive one round of the field. Another person, Ravi, takes 12 minutes for the same means for one round. If they start at the same time, start means both Sonia and Ravi, and also they are traveling in the same direction. After how many minutes they meet once again at the starting point? C. Solution. Circular path. If I take A as Sonia, B as Ravi, they are starting in this direction means Sonia takes how many minutes to cover one round? 18 minutes. One round. For Sonia, 18. Again for Ravi, the same direction. Again for Ravi also takes one round. How many minutes? For Ravi, 18 for Sonia, Ravi 12. Okay. Again Sonia takes another round, that is second round. Next 18 minutes, 36 minutes. For Ravi, second round, 24 minutes. Again Sonia, next 18 minutes means 54. For Ravi, another 12 minutes means 36. See, for Sonia, multiples of 18, for Ravi, multiples of 12. Here simply we can find the answer by not solving the problem. Common minutes 36. For the question they asking how many minutes will they meet again at the starting point means simply we can say 36. But we can prove mathematically. Solution: the minimum time they will meet is LCM. Why LCM? Because for Sonia multiplicity of 18, for Ravi multiplicity of 12. I am taking a common value here 36, here also 36. The minimum common multiplicity, that is least common multiplicity of which one? 18 and 12. I am going to find LCM of 18 and 12 for the problem, which will give the minimum minutes they meet again at the starting point. First find the factors for 18. 2, 9, 3, 3, 3, 1. 18 can be written as 2 into 3 square. Now I am going to find the prime factors for 12. 6, 2, 3 are 3, 1 are. For 12, 2 square into 3. LCM, greatest power of the prime factor. Here 3 square, here 3. Greatest power means 3 square. Here 2 square. Greatest power means 2 square. 3 square is 9. 2 square is 4. Answer is 36. For the problem number 7, minimum minutes they meet again at the starting point, 36 minutes. I will upload more problem from the chapter 1 real numbers for the CBSE class 10 mathematics students in the upcoming videos. You just subscribe my channel, share my channel to your friend and like my channel. Thank you.